I should have pushed that button earlier. Let's go recording. My room is feeling awful, very weird. Chemistry department temperatures are always messed up. Okay, definitely something is wrong with my front camera. Hold on, video setting. Yep, mirror my video. Don't do that. And it should be HD. All right, now it looks good. Nothing else is screwed up. Maximum participants displayed per screen. No, I want 49, not 20. All right, so we are recording. So let's go to the board. We're going to start talking about. Something new. Okay, we're going to wrap it up quickly and then talk about carbonyl chemistry for the last 3 classes, and that will pretty much be it. All right, my phone is off. Let's go. So we're going to talk about something different. Okay, you have realized that M8, and I have no idea what day is today. 20. Wow, April 20. 4/20/21. We're going to talk about alkyl halides. Okay, we will. I'll tell you why. Alkyl. I'm going to change the color of the halide part. Alkyl halides. They're special molecules. Okay, and the type of reaction that you're going to be seeing are going to be called substitution reactions. Okay, they're going to be called nucleophilic substitution reaction. Okay. Now you have realized that you have seen so far that these guys that's kind of like our goal today. Okay, you have seen that this sort of molecules, butane, I don't know, pentane, substituted molecules, cyclohexane, these molecules where you have nothing but carbon and hydrogen, they're very stable. You have probably been, I haven't really told you, but these sigma bonds, the molecules with sigma bonds, they're all sigma, right? Everywhere you see everywhere is sigma. CH bonds are sigma, CC bonds are sigma. They're very strong, stable bonds, okay? All these molecules are very unreactive. Okay, these guys are generally pretty unreactive. In order for a molecule to be reactive, there has to be a pi bond in general, except for the time when we have alkyl halides. Generally speaking, you have to have a pi bond to make it unstable. Okay, so that makes it unstable or reactive. Okay, so an alkene is reactive, an alkyne is reactive. There is not much space, so I'm going to draw it upside down. Okay, so it's got 2 pi bonds. I'm just using different colors. Hopefully you guys can see it. So this guy is also reactive. Okay, so this molecule is unreactive, unstable and reactive. This molecule is also unstable and reactive because of the pi bond. So that's the general rule of thumb you have gotten used to so far in this class, right? So other than pi bonds, the question is, can you have a sigma bond that's unstable? Well, so this is kind of on the side, okay? So the question is, unstable sigma bond, okay? Is there something that exists that's unstable sigma bond? Carbon-carbon sigma bonds, carbon-carbon, carbon-hydrogen sigma bond, they're very stable, right? So yes, the answer is yes. And alkyl halide, when you have an alkyl halide, the carbon halogen bond is unstable. The answer is yes. Okay. And the kind of bond that's going to be unstable is carbon halogen. The answer is carbon halogen bond is unstable. Okay. And where X is a halogen. So, such as fluorine, chlorine, bromine, or iodine. Okay, so that's the deal. Okay, so what's going on here? And if you have a alkyl halide, what does it react with? Who can replace or who can do whatever terrible things to this carbon halogen bond? All right, so let's take a look at it. So when you have an alkyl halide, what does it look like? Well, we will first use a symbol. Like, how do you use like a how do you symbolize an alkyl halide? This is how you symbolize an alkyl halide. When you talk about alkyl halide, you see I have color coded it. The black alkyl and red halide. So usually we say an alkyl halide is written this way. Rx, okay, that's an alkyl halide. R is an alkyl group. X is a halogen. It's not that difficult. Rx reacts with, and this is the bond that's vulnerable. Weak, vulnerable. This is the sketchy part of the town, sketchy part of the molecule. The carbon halogen bond is a little sketchy, and bad things can happen there. Okay, so what happens when an alkyl halide encounters a nucleophile? We talked about nucleophiles. Excuse me. Nucleophiles are species that have extra electron. So nucleophile means nucleus loving. Nucleus loving means nucleus has plus charges. So if I'm a nucleophile, that means I love nucleus. That means I can help a nucleus feel better. That means I can help a positive charge feel better. That means I have extra electron density that I'm not using. Okay, so either I'm a neutral guy with a lone pair, or I'm a negatively charged anion. I could be an F minus, I could be an oxygen with two lone pairs, I could be a nitrogen with a single lone pair, I could be a carbon with a negative charge, I could be an oxygen with a negative charge, a super oxygen nucleophile. I could be a hydrogen with a negative charge. All these negatively charged species in the laundry list of nucleophiles, they're the super nucleophiles because they're negatively charged. They're more reactive than a neutral nucleophile. Neutral nucleophiles will be water and alcohol, oxygen with two lone pairs. Okay, the one lone pair can be used to help someone. Okay, so all these guys are nucleophiles. So when an Rx reacts with a nucleophile, okay, I'm just going to say this is going to be our symbol for a nucleophile. NU, nucleophile, the first two letters, and with a lone pair. That means it has to have a lone pair. So that symbolizes that it's a nucleophile. Nucleus loving, that means I have extra electron pair. So that's the deal. So what does the reaction look like? So what happens when an alkyl halide reacts with a nucleophile. Well, something terrible happens. It's kind of like, this is like a like a teenager son or daughter at home, and he or she has just crossed her 18th birthday and feeling pretty confident, and she wants to be alone. She has a job, she's going to school, she's taking classes, and she's making enough money to pay for an apartment. So she says, Dad, Mom, I'm going to be renting an apartment. I might share with some of my friends. They're all in our music group, and I'm working and I'm going to college. So parents say, sure, no problem. So what do we do with your empty room? Well, we find a paying guest, and he or she comes in and stays in your room and pays us some money. So parents like it, right? So X is happy to be out of home as a single person, independent person, and it leaves the house. So this is your living room. Okay, it's literally called, I'm not making it up. X is the halogen is actually called a living group. It leaves that nest. Okay, and this is the nucleophile that replaces X. So the paying guest replaces the grown-up daughter or son. So as a result, what does it look like? Well, it looks like this. Paying guest is in, nucleophile is in, and the 19-year-old or 18-and-a-half-year-old daughter is out. Okay, and it came out with the bonding electrons. Okay, therefore it has extra electron pair, and therefore it is minus charged. Okay, so that's what happens. So if I now ask you, based on what you have heard so far, if I ask you what kind of reaction is this, you have three choices. The question is type of reaction. I'm kind of abbreviating. Okay, answer A, it's an addition reaction. Answer B, it's a substitution reaction. Answer C, it's an elimination reaction. I am not going to explain everything. I'm going to expect you to kind of connect the dots and give me the correct answer. Take your time. Take about a minute. Okay, I'll try to keep my mouth shut. I have always been told by my colleagues and peers that I never give you guys enough time. Like in general, I mean students. Okay, I'll shut up. What kind of reaction is this? Rx plus nucleophile, R nucleophile plus X minus. Addition, substitution, or elimination. Use your best judgment. And when you're ready, say that I'm going to answer. And I prefer that somebody who usually doesn't answer answers this time, not the usual suspects.
I'm going to answer.
And who is this? Hold on. You are Rosemary. Rosemary, go ahead.
Substitution.
Substitution. Okay, I got excited, but I'm trying to keep my face neutral so that I'm not saying yes or no. Okay. So Rosemary says, almost sounds like DMV. Rosemary who? Rosemary says it's B. RMV. Recreational motor vehicles. See? That's you. Okay. Is Rosemary correct or Rosemary wrong? Oh, Rosemary, your cup is bigger than my cup.
Hey, cheers.
Yes, okay. Is Rosemary correct or not? What do you guys think?
I agree with Rosemary on that one.
Danielle, what?
Sorry, my voice is
yes,
like.
Okay. Yeah. Okay, Danielle thinks she's correct. Substitution? Substitution. Substitution reaction. Okay, so what is this reaction called? It's called some kind of substitution reaction. Okay, so let's put the name together. Let's do the naming ceremony first. Okay, the child is born and we need to name that person. It's a person. Okay, our neighbors' kids are looking like people now. They were like tiny, they were horizontal, now they're vertical. So I call them person, they're like human beings. Okay, so they're called,
It's an alkyl halide, but the alkyl halide is important. The nucleophile is also very important. So this reaction is called nucleophilic substitution. It's called nucleophilic substitution. Then there is a third word. It's called either bimolecular or unimolecular. Okay, I'll explain, and it'll take a little time because we have to like use real molecules and kind of lay it down and explain in details. Okay, so I'm going to just write it down here. Nucleophilic substitution. The last word is either bimolecular or unimolecular. Okay, so this reaction is called nucleophilic substitution, bimolecular or unimolecular, and it has a symbol. Okay, and this is how it's written. S for substitution. Okay, S, N for a small n, but it's uppercase N, like a full uppercase S, kind of a smaller font uppercase N, and then either 2 or it's called Sn1. Okay, so it's either Sn1 or Sn2. Sn means substitution nucleophilic bimolecular, 2, substitution nucleophilic unimolecular, 1. We will now get into the details of this reaction. Let me take a snapshot. I don't think I can put any more stuff on the board. It's pretty full. I'm sorry, I'm blocking the camera. Okay, take a look at the board, what we have discussed. Not much to ponder, but just stare at it. All right. Rx plus nucleophile, R nucleophile plus X minus, nucleophilic substitution, bimolecular or unimolecular, and it's called Sn2 or Sn1. What we will do now is I'm going to clean up the board, divide the board into 2 parts. We will go for Sn2 on the left side and Sn1 on the right side, and just write down how these reactions happen. You know, I should probably have a special column for nucleophiles. What do the nucleophiles look like? We have done it in the past. I don't know if we have done it in the past. We may have done it in the past. I'm going to just do it now so that you have a list of nucleophiles right in front of your eyes. All right, let's go on a cleaning spree. All right, let's clean up the board and talk about this chemistry. This is pretty straightforward, and substitution reactions will probably carry a lot of weightage for you guys in the final and in the upcoming quiz. When is the quiz? May 4th. May 4th. All right, May 4th. Somebody's knocking on my door. Teaching. That's okay, no problem. And after some time, I'll text you. Okay, sorry about that. My research student is about to graduate and go for PhD. He's going to use San Diego for his PhD. He's a little cocoa up here. They're all a little eccentric, which makes the world interesting, right? Otherwise, it will be so boring. So he's busy doing the knowledge transfers. I told him that make sure that 2 new students know what you know, so that I don't have to train them. All right, so let's write down the list of nucleophiles. You have, I can't remember right now, but I might have done it. So let's draw the nucleophile list. Okay, nucleophile should be written in blue. I don't know why. That's the norm. Okay. Nucleophiles. First nucleophile, the simplest nucleophile, water. Why is it a nucleophile? Well, you see the bunny ears. That's why it's a nucleophile, because it's got lone pair. If it has a lone pair, it can probably, push it somewhere where it's necessary when there is positive charge, or somebody can be utilizing that charge. Okay, that's an okay nucleophile. It's a neutral nucleophile. If you want the same deal, if you want the same product, OH, but if you want that in a more super duper package, this is what it's going to look like. It's going to be OH minus. You pull the hydrogen from this side, okay, using a strong base, and then make this oxygen negatively charged. Okay, what kind of package can this OH minus come in? Sodium hydroxide, it's a base. So sodium hydroxide will be providing you with the same nucleophilic species that water has, but in a better package, okay, more powerful, stronger nucleophile. All right. So that's water, that's OH minus, hydroxy, and negatively charged anion. Any alcohol. Any alcohol, methanol, ethanol, isopropanol, butanol, octanol, any alcohol is a nucleophile. Okay. Can you do the same deal like OH minus? Of course you can. You can pull this hydrogen off using something like sodium or potassium or some very strong base, and then you can do the same business here. Okay. OR minus, some alcohol, and then there has to be a positively charged species on this side, sodium or potassium. Let's put potassium here, just for diversity. Okay, that's that. Okay, can you have nitrogen nucleophiles? Absolutely. You can have ammonia. That's a nucleophile, right? I need to keep an eye on the clock. Can you have an amine? What's an amine? Amine came from the atom of amines is ammonia. Okay, you start replacing the hydrogens one at a time with R groups, alkyl groups. Okay, so when you replace it with one R, okay, and you still have the lone pair up there, this is a fantastic nucleophile, and it's called a primary amine. Okay, can you replace 2 hydrogens in ammonia with 2 R groups? Sure, we can do that. It still has the lone pair. Okay, and it could be R and R, and this guy is called, when it has only one NH, one hydrogen attached to the nitrogen, it's called secondary amine. That's a secondary amine. Tertiary amines exist, but they don't function as a nucleophile. They function as a base. We don't have to discuss that right now. It's going to be a distraction for me and you guys. Okay, so that's that. Can you have a hydrogen nucleophile? Well, hydrogen is born this way, right? This is what neutral hydrogen is. Hydrogen is born with one proton and one electron, right? That's how hydrogen is. We know that this is possible, H plus, and that's called a proton. Okay. Can you have a H nucleophile? Well, sure. You can have H with 2 electrons, very unstable, very reactive. It's H minus. Can it happen? It's difficult, but can you make it and can you package it somehow? Absolutely. What is it called? It's called hydride. Okay, it's called hydride. H-Y-D-R-I-D-E. So that's the tiniest nucleophile you can think about. Okay, sure. So you can have H minus. How can you? What kind of package does it come in? There are 2 packages. I'm just going to tell you what they are called. Memorize it. I don't have to show you the structure at this point. They come in 2 packages. One package is called sodium borohydride. You know what? Let me just write it down. It's called, you should probably know the name. Sodium borohydride. Another package is called lithium aluminum hydride. Lithium aluminum hydride. And this guy's, I'm going to write it down. Lithium aluminum hydride. Okay, they both give rise to H minus. Their job is to produce. So if you see one of those reagents, lithium aluminum hydride or sodium borohydride, you shouldn't freak out. All you should think is close your eyes, take a deep breath, and when you see one of those reagents, you think H minus. All you have to deal with is H minus. Use H minus as a nucleophile in the substitution reaction. That's all. So don't panic. So H minus is possible. Can you have a carbon nucleophile? Yes, you can have a carbon nucleophile. I'm just going to show you one reagent. So that carbon nucleophile is going to be R, okay, whatever that R is. And then it's attached to a magnesium, RMG. And on the other side of magnesium, there is a halogen. I'll use some examples. Okay, what does it do? It produces, because magnesium is less electronegative than carbon, so this makes this R group slightly negatively charged. So you actually have a carbon nucleophile. And these guys are called Grignard reagent. Okay, I'm going to write it down in green color because it sounds like green. Okay, GRIG, the second G is silent. We didn't know that in India. We used to call them Grignard. Then I was ridiculed when I came here and said Grignard reagent. My fellow graduate students were like, they're trying to control the laughter. Like, this idiot is caught, doesn't even know that the second G is silent. So, you know, it happens. You get bullied and mocked. So Grignard reagent. Okay, where R is minus charge, like nucleophilic. So oxygen nucleophile, neutral, Simple, awesome. Oxygen nucleophile in the form of alcohol, neutral, okay, awesome. Nitrogen nucleophile, ammonia, primary amine nitrogen nucleophile, secondary amine nitrogen nucleophile, hydrogen nucleophile, and carbon nucleophile. We're going to use some examples so that you understand what exactly we are dealing with. Okay, so let me just block this area. I may actually delete this part. That's the list of our nucleophiles. I think it's a good idea for us to have it. Okay, I may erase it. Let's see how much space do we need. And we are at 8:37. I think we're doing fine. Okay. We don't need that. It's in the video. It's not going to be in the picture. That's fine. You've already seen hydrogen and proton many times in the past this semester. So let me split the board into half. It's not a mirror, it's just a line, okay? On the left side, we're going to talk about Sn2. On the right side, we're going to talk about Sn1. Okay, and we're going to write down some bullet points, and I think I want to wrap it up as quickly as possible. If we have an extra day for carbonyl chemistry, it'll be actually good. Okay, I need some coffee. Okay. I drink coffee like water. Okay, Sn1 and Sn2. 2, that's important. Substitution nucleophilic bimolecular. We will talk about why it is bimolecular. So I'm going to use a real molecule, not Rx, not that kind of fictitious molecule. Okay, let's use a real molecule. Let's say we have, let's write that down. CH3 CH2. This carbon is important, so I'm going to color them blue. And a halogen. How about a bromine? Okay. Alkyl halide. Okay. So, and we're going to use one of those nucleophiles. Let's use this dude. It's kind of like my favorite. Simple, something you have seen in 1A or 3A and 3B or 1B, wherever you came from, your past town. So NaOH is base. You have seen it. You have seen it in probably as the pellets or solution, right? So let's put some sodium hydroxide here. Okay. Sodium hydroxide. Okay. What happens when they are brought together? And usually the reactions are done in round bottom flasks, like glass flasks. You put them together with a solvent and you stir them using a magnetic stir bar. Okay, it's coated with Teflon and it's placed on a magnetic stirrer. It has a little disc that's magnetic that spins, and it induces that spinning motion inside the flask to that magnetic stir bar. It's a metallic iron star bar coated with Teflon. The Teflon is important because otherwise the iron can react with your compounds. You don't want that to happen. You want your whatever is inside the flask, you don't want them to react with your compounds. So Teflon coated stir bar, and it spins, and the whole solution spins, and it does pretty good mixing. Okay. Sometimes we heat, sometimes we reflux. Reflux means we heat up and we put we recool, condense the vapors back, and so that they don't escape. You don't lose all your solvent. So there are many ways to run a reaction. Okay. So when you do that reaction, what you get out, well, alkyl, this is the alkyl part. That's the halogen, that's the leaving group, okay? So this is, okay, let's use proper color. black dot for carbon, black dot, black dot, black dot, right? That's red dot coming from bromine. I'm not showing all the electrons around bromine because it gets very complicated and it distracts you. Okay, I don't want you to be distracted right now. Let's keep the picture clean. And the hydrogens are up there. Hydrogens are important. Okay, the carbon that is directly attached to the halogen or directly attached to the important functional group, that's sometimes called alpha. Okay, so this is your, let's use a different color. Let's use this color. This is your alpha carbon. This is your beta carbon. Okay, alpha means right next door to the important place. The important place is the halogen. Alpha, beta. That could be a molecule where you could have 2 betas or 3 betas or gamma, things like that. We will see. Okay. Okay, all right. So what happens in this reaction? Well, this goes, this is out, and this is in, right? That's the deal. So the resulting reaction, the product will look like this. This is out, that's in. I'm not drawing every electron, so I'm just drawing the important electrons. Okay, so from alkyl halide, bromoethane, you just made ethanol. It's pretty cool, right? You just figured out how to make ethanol, right? Substitution reaction. How does the reaction happen? I'm not going to be really hung up on asking you about the mechanism, but I think you should know. It's not rocket science. You can handle it. It's pretty straightforward. How does this reaction happen? Well, very simple. In Sn2, the paying guest jumps the fence from your backyard. Sounds very creepy and bad. The paying guest is ready to come in. The daughter or the son who is going to be kicked out from the house, or willingly or unwillingly, is still there. The paying guest jumps in, enters the house from the back door. Back door is important. From the back porch, and the child is kicked out from the front door. The child goes out from the front door. The paying guest comes in from the back door. It all happens simultaneously at the same time. Boom, boom. Okay. Backside, front side, the living group is gone. So how do we show it? It's pretty straightforward. Just 2 simple arrows. You can handle it. Boom, boom. It's that simple. Take a look at it for a second.
Do we also get because there is a sodium there, right? Does that sodium combine with the bromine for sodium bromide, or does it not really matter here?
Sodium, is for the time being, ignore it. Yeah, you're right. Sodium becomes sodium bromide. When you do the water wash, it gets extracted. It gets washed in the water wash. At the end of the day, if you do that reaction, actually you're an intern or you're a volunteer in one of our labs. And if you're actually doing this reaction, you will be doing some water wash. As you do the water wash, it will produce sodium bromide. Yes, you're absolutely right. Let's write it down. Thank you. So that can be washed in water. Washed with water. The baby is born, it's time to clean it up. When you clean it up, then all these byproducts get cleaned up. Okay? Take a look at it and make sure you understand what's going on here. Then I'll show you the second type of reaction, and then we're going to write down some bullet points. I think we may drag this discussion maybe 15 minutes or half an hour into Thursday, but then I don't want to drag it longer than that. Okay? Take a look at it while I drink more coffee. I think I still have like maybe about 4.5 minutes left. I try to drink the last drop. All right. So far, so good. Well, I'm not gonna talk a lot about the properties of this reaction. This is Sn2. We still haven't discussed Y2. Why not 1? What does 2 signify? We'll discuss it after I show you the other type of reaction. The mechanism is different. The end product is very similar. Okay. All right. The second type of reaction, this is one type of alkyl halide. The second type of alkyl halide, I'm going to draw it a little differently. Okay. It's going to be a slightly different looking molecule. Let's make it look very similar. Let's see, we can name these alkyl halides. I'm not going to spend an awful lot of time on naming alkyl halides, but I think we should spend some time naming alkyl halides. So alkyl halide, the halogen is called halo. So fluorine, when it's a substituent as a fluoride, it's called fluoro. Okay, I'm going to write it down somewhere. Where am I going to write it down? We don't have any space. So I'm going to write it down maybe on this side. So fluorine becomes FluORO, fluoro, chloro, bromo, and iodo. Okay, when they are present in a bigger molecule as a group. So how would you name this molecule? CH3CH2Br. It's not rocket science. It's really simple. I want someone who usually doesn't talk. I want a shy person to speak up today and take a shot at naming CH3CH2Br. Not the usual suspects. Please control yourself to not talk, which is not easy for me. Anybody? Where is the shy guy or shy girl? Any shy person here? Any introvert? What's the name of this molecule? Come on, you shy guy.
I'll take a shot at it.
Who is this?
It's me again.
Rosemary. You're smelling good. You're doing good. Okay.
Uh,
We just killed our rosemary bushes in our backyard. We tried to transplant and they're not doing well. So you need to come and do your magic touch. Okay, what's the name of it, Rosemary?
Is it bromoethane? Or 1-bromoethane?
I'll take what you said first.
Okay.
Okay, bromo. What do you guys think? Anybody? Cheer or jeer? Boo or clap, applaud? Any supporting sound or not supporting sound? Quick. I'm racing against time. I want to finish a little bit more. Hurry up, boys and girls.
I think that's good. Yeah, bromoethane.
Bromoethane sounds good. 1 is not important because there is no true bromoethane. If you put the bromine on the left side, it's the same molecule, bromoethane, right? Okay. Anybody who hasn't spoken today, and Rosemary is banned from speaking up again. Okay, you are forbidden. Okay, everybody else is forbidden too, like those who usually talk. What's the name of this guy? Figure it out. How would you name that molecule? It's also going to be something bromo, whatever. So who hasn't spoken? Let's say who hasn't spoken today? Speak up. Anybody? Anybody who falls in that category? Find the longest chain. Bromine is a substituent. It's going to be called something, something, something else. 3 components in that name. Some hyphen, some comma, maybe, I don't know. Longest chain and 2 substituents. You can do it. Okay. Anybody who is willing to take a shot at it. Rosemary.
Yeah, I'll go. Bromobutane.
I'm making this horrible grunting sound.
I'll take a swing.
Hold on. Rosemary, is butane the longest chain? Longest chain is boom, boom, boom. There is no butane, right? That's the longest chain. 1, 2, 3, right? So if I draw this molecule here, like that, this is the quintessential chicken foot molecule, right? That's the chicken. The bromine is the chicken, representation of the chicken, and that's the foot, chicken foot, right? So what's the longest chain? The longest that there is no butane longest chain. The longest chain is this. So what's that chain called? Yeah.
Propyl.
What did you say?
Or is it propyl?
Not propyl. It's the longest chain. That's the mother of the molecule. So you call it whatever
Propane.
the alkane is called, propane. Right? So that's one group, and this is another group, and it's this dude is going to be called something propane. That thing propane. Figure it out, Rosemary. I want you to crack the code. Now what is it? What kind of propane is this? What group is this? CH3, and what group is this? Br. What is the Br going to be called in this molecule? It's going to be called bromo. What about this group, CH3? What is that going to be called?
I think I got it. Okay.
Okay, spit it out.
Okay. 2-bromo methyl propane.
2-bromo
Or
hyphen. Where is the methyl?
2-methyl.
Where is the methyl?
It's at 2. So 2-methyl and
Yeah.
then propane.
I'm not going to spend any more time with alkyl halide nomenclature. We are done with naming alkyl halide. You guys figure it out. Figure out the rest. Okay. I'm really not excited about naming molecules. So you have to kind of understand your instructor's problems, psychological problems. We all have problems. Okay. Don't give me that dirty look. Okay. So 2-bromo, 2-methyl butane. It's also called tertiary butyl bromide. Let's not talk about that. I shouldn't have said that. Okay. Let's use the same. What is that called? Nucleophile. So it reacts with sodium hydroxide. Okay. In this reaction, that mechanism, boom boom reaction, doesn't happen. The paying guest does not jump the fence. Before the paying guest can jump the fence and enter the house and kick out the kid goes out. Kid leaves the house first. Okay, so what happens? There are 2 steps. This is a single step reaction. Only one step. This reaction is 2 steps. Okay. In the first step, what happens is this thing happens. Breaking bond. Breaking bond happens in step 1. What does it look like? Well, it looks like this. This is gone. Bromine is out. This is step 1. You form a carbocation. what does the carbocation look like? You know what? I should probably spell it out a little bit. The chicken foot has detached itself from the chicken. It's not funny, I know. That carbocation forms. Why does that carbocation forms and why does this carbocation doesn't form? We have discussed it in the past. If it did the same thing, this carbocation would look like this. If it forms, I'm going to put it in parentheses. If, big if, this carbocation had formed, that's how this carbocation would look like. And over here, this carbocation has already formed. We have discussed it in the past. We have discussed it based on electronegativity differences. Like some carbocations are happy, some carbocations suck. They're horrible. Okay, that's a bad carbocation. This is a primary carbocation. Primary carbocation or 1 degree carbocation because it's got 2 hydrogens attached to the carbocation center. This guy is called a tertiary carbocation. Why? There is no hydrogen attached to the carbocation center. There are 3 alkyl groups. What's the big deal about an alkyl group? Well, alkyl group is a big deal because electronegativity wise, hydrogen is 2.1 or 2.2. It depends on which book you look at. Carbon is 2.5. Okay, that means it's pulling electron density toward itself. And I always use that metaphor, right? You are standing in a line trying to get movie tickets in front of Maya Theater, and I'm surrounded by, I have 3 triplets, not my triplets, let's say our grandchildren. We probably have to wait for another 10 years. Hope we don't have triplets. Excuse me. The 3 little, like, very naughty and rambunctious kids, they're pushing me. Okay, if they're pushing me, there are 3 hydrogens. I end up pushing the person who is standing in front of me. I probably get scolded by the person. Like, what is wrong with you? Why are you being obnoxious, right? So when the little triplets are pushing the carbon, mama carbon pushes the guy in front of herself in the line. So what happens? It exerts some kind of, there's an electron density push from that carbon-carbon bond toward the carbon deficient center. If I don't have money and if you're pushing some money toward me, I'm going to be a happy person, right? So this carbocation center gets some help from 1 alkyl group. Over here, look, three alkyl groups. 3 alkyl groups are pushing electron density to that carbocation center, okay, which is deficient of electron density. That means this is really happy. In other words, the correct term is stable. It's stable. This is not stable. This is unstable. Okay, because it's unstable, it does not happen. That's why the kid gets kicked out simultaneously at the same time when the paying guest jumps the fence and enters the house. Over here, the house is happy without the kid. This is the house without the kid, and they're used to it. Because the kid has gone out for internships and other projects and other outings and stuff like that. So the parents are pretty used to, right? So This is a happy molecule. This is step one. In step one, the nucleophile is not even in the picture. The nucleophile is just waiting outside the line, the periphery, and watching the game. Like let that person leave, then I'm gonna start getting into my action. So step two is when the nucleophile comes in. What does the nucleophile do? Well, OH minus and sodium plus. Okay. Now, after the house is empty, the front room is empty, the nucleophile can come in either from the top, from the front door, or from the back door. It doesn't matter. Okay. Nucleophile then attacks and makes the final deal, final product. And the final product looks like an alcohol. So this is step one, and this is step two. Okay, so, and this is a tertiary alkyl halide. This is a primary alkyl halide. This is getting pretty crowded, so I'm going to write it down again. Primary alkyl halide, and this is tertiary alkyl halide. Okay, we're going to write it down. So when you have a tertiary alkyl halide, it goes through a two-step procedure through a carbocation. When you have a primary alkyl halide, it goes through a single step. When the alkyl halide and the nucleophile are both present, and it's a boom boom, same one-step reaction. Everything happens at the same time, okay? And you get the product. Okay, so let's write down some bullet points. 903. Take a look at the board. I'll try to keep my mouth shut for a minute. It's going to be a challenge, but let me see if I can do it. Take a look at the board, and then what we're going to be doing today for the rest of the class for another 10 minutes or so is write down some bullet points and compare left side and right side. Okay, so take a look. I'm just going to see my phone. I'm just going to stare at the phone. Sn2, Sn1. We haven't discussed 1 and 2 yet. So relax. We'll talk about it. Primary alkyl halide, tertiary alkyl halide. It cannot form a carbocation for reasons we have discussed. This guy undergoes the reaction in one step without going through that carbocation step. It gets, the living group is kicked out same time when the nucleophile comes in. Over here, nucleophile, before nucleophile comes in, nucleophile is not in the picture. I shouldn't have drawn that. Nucleophile is not even there. Okay, this guy just breaks down into two parts. The living group leaves, you form the carbocation. This carbocation is a good carbocation. Tertiary carbocation is a happy carbocation, stable carbocation. That's why it happens. It doesn't happen because it's a bad, unstable carbocation. It forms, the living group is gone, just like there. And then the nucleophile comes in and forms the final product. Okay, take a look at it. Okay. So far, so good. I'm not going to take any questions. We will take questions on Thursday. Okay. So let's write down some bullet points. Bullet point number 1. Okay. Bullet point number 1. Bullet point number 1. Can you distinguish reaction 1 on the left and reaction 2 on the right? Throw some bullet points and I'll write it down. What's the first bullet point that comes to your mind? Something specific about this reaction. Anybody, everybody, like give me like 1 point that I'm going to write down across this blue star. Say something about it. What do you see? The difference between the two reactions.
Sn2 is simultaneous while Sn1 is two-step.
1 step, 2 steps. Excellent. Thank you, Rosemary. Bullet point number 2. Somebody else. Say something else. Anybody. If you want to give me like 5 bullet points, Rosemary, you're welcome.
Sn2 is primary and Sn1 is tertiary.
Primary alkyl halide. I'm just going to say primary RX. Save space. That means alkyl halide, okay? Primary RX. This is tertiary RX. Great, excellent. Bullet point number 3.
Sn2 is unstable, Sn1 is stable, happy.
Articulate a little bit more. Unstable what? Instructor?
Carbocation?
Let's put it in a slightly different way. The carbocation doesn't happen on the left side in Sn2. So let's not talk about carbocation in Sn1. So let's rephrase what you have in mind. Something doesn't happen in Sn2, something happens in Sn1. What is that something? We just talked about it.
We get a carbocation.
No carbocation. Carbocation. That's not very convincing, but you get the point. Carbocation. Okay. How about if I say something about how the nucleophile attacks in Sn2 versus Sn1? Where are we with time? 9, 10. We have 5 more minutes. That's awesome. Finally, I'm learning. Okay. Say something about the nucleophile attack. Anybody? Somebody, preferably not the usual suspects. Not Michael. I was going to call you William again. Not Michael and not Rosemary. Something about nucleophilic attack. How does the nucleophile do its business? Come on, wake up. Hey, Willis, you're too close to the cameras. Say something.
Like what?
Like what?
Yeah.
Are you sleeping with your eyes open?
No.
Okay. Anybody else? I don't want to, catch you off guard. Craig, you have been too quiet.
I think for Sn1, you said it can be attacked by the front or the back door. And I don't remember what you said for Sn2.
Nucleophile attacks from front and back. Nucleophile. Ooh, the dots, the umlaut attacks only from back. What else? What else we can say depending upon, based on what we have learned so far? I know there are 3 other things that are important. I don't want to talk about what I have in my mind. I think this is probably pretty good. Yeah, I don't know if I should delve any deeper. I'm just trying to think like if there is something that can be added here. Otherwise, we are pretty much done with what I wanted to talk about in Sn2 and Sn1 reaction. I'm just going to show you. It's not that imperative for you to kind of memorize it, but I think it's important. Maybe there will be a bonus question. Maybe there'll be 1 or 2 questions from this, what we're going to be discussing now, and that will be considered like a bonus question. So 1 or 2 questions will be a little hard in the final, okay? So I'm thinking final. So if we draw like a reaction coordinate, I think you should learn it. It's not that difficult. You can handle it, okay? Even though you're not chemistry major or biology major. Some of you are. So reaction coordinate means 9:13 is not going to happen today. Let me see if I can think about something else. Yes, we haven't talked about number 2 and number 1. That sounds funny. Okay. Let me ask you this question. Why this is a 1-step reaction? This is a 2-step reaction, right? But we call that reaction Sn2 and this reaction Sn1. What's the significance of 2 and 1? Let's discuss that for like 2 minutes. Let's call it a day. Why is this Sn2 and why is this 1, even though this is 2-step and that's 1-step? It's like contrary to your instinct. Where is 2 and 1 coming from? What's 2 here? Anybody has any?
It's bimolecular.
Bimolecular, what does that mean, Craig? Bi means 2,
so,
right? 2
yeah.
molecule. It's a 2-molecule deal and it's a 1-molecule deal. Where is that coming from?
So it's coming from the bromoethane and the NaOH, which are 2 separate molecules, and then on the other hand, the Sn1 is the 2-bromo-2-methylpropane reacting with an electrophile, but that electrophile, I guess, is
No electrophile, it's a nucleophile.
a nucleophile. Thank you.
Yeah, both cases, the 2 molecules are involved, but there is only 1 step. And in that step, how many molecules are involved on the left side? In the only 1 step, that's the reaction step. Is 1 molecule involved or both molecules involved in the same step?
So they both swap out different components of the molecule with each other.
So the bottom line is, during the only step, during the only, whenever something is happening, both guys are involved. Mm-hmm. The carpenter and the plumber, they're both working simultaneously to make the modification in the kitchen happen, okay? So it's called bimolecular. Both molecules, I'm just going to write it down and call it a day. So just hanging there for a few more minutes. Molecules involved in the only step, okay? Both molecules are involved. Over here in the step 1, which happens to be the important step, we will maybe discuss it on Thursday just a little bit, okay? Only 1 molecule which is the Rx, involved in the first, and it's important. Take a note, I'll explain it on Thursday. And it happens to be the slow step. In the first and slow step of reaction. And therefore, this is called unimolecular. Okay, this is called unimolecular and this is called bimolecular because in the first step, which happens to be the slow steps are actually important because that determines the fate of the reaction, how long the reaction is going to take, how fast it's going to be done, whatever is happening during that step are very critical. The second step is very fast. Okay, so this is if you have a journey starting from here going all the way to here, the first step of your journey will determine how much time you're going to take to get to the final destination, because this is just boom, very quick. Okay, that's much faster. So the bottom line is in the slow step of the reaction, there is only one molecule involved, which is just the alkyl halide. The nucleophile is not involved. Therefore, it's called unimolecular. A common mistake that's made by our students in the past for the last 12 years, I've been seeing people usually swap it because it's a one-step reaction. So usually students will say that's Sn1, and that's a two-step reaction, and students will say Sn2, and you get knocked off. Points get knocked off. That's not good. It's opposite to your instinct. Like one of my friends told me once that when he was frustrated with my sense of direction, he said, whatever an instinct is, just do the opposite and we'll get to the destination. He was really fed up. I kept saying, taking the wrong turns in Berkeley. He was a student and he said, Shantanu, if you feel like taking a left turn, just do the opposite. There was something about that in Seinfeld, the old sitcom, like they were doing the opposite and George was getting very successful with his life. Okay, no distractions. Spend some time going over this concept that we have just covered in our class. It's important. It's not as easy as you think. You need to really keep a lot of dots in mind and how they're connected, okay? It's very easy to screw up. So we're going to continue our discussion maybe for 15 minutes or half an hour on Thursday. Then we're going to switch to maybe talk about just a little bit about elimination reactions. I'm just going to tell you like what they are, and then start talking about carbonyl chemistry for the next, I think we'll have three more lectures left after that, okay? On May 4th, there is a quiz, and then there will be a final. May 6th, there will be a review, okay? So you guys have a good day, and I'll see you on Thursday. I'm gonna take a snapshot.
Thank you.
No problem. Bye, Rosemary. Bye, everybody else.
What
Thanks.
time did you say that the review was on May 6th again?
May 6th, 8 to 10.
8 to 10. Okay,
Yeah,
thank you.
I'm gonna send an announcement too,
Okay,
just
perfect.
as a reminder. You guys
Thank
be good. Do some studying. Don't blow the final exam and the last quiz. Please do well. I want you guys to do well. Okay. Bye, everybody. Now you can go and run around your neighborhood. Bye. See you soon.